Today I want to explain the solution to the problem 2 in homework 8. For this problem, firstly we need to draw free body diagram and like this. And we from the free body diagram we can know the F1 equals K1 times X1, F2 equals K2 times X2 minus X1. Then we can get the equation of the motion of the M1 and M2, and then we get the equation just M1 x double dot x1 equals to minus F1 plus F2, and M2 x2 double dot equals minus F2, and we get equation. Then we write this equation into the matrix form, and so then we get this form, and just use these two equation. To simplify this form, we can just use M to represent this matrix, and K to this matrix, and X is equals to this, and K X, and then solve the problems, we need to assume x equals v times est, and t is time, like equation, and then we plug the v times est into this formula. We get this formula, and double dot just derivative x 2 times, and we get this formula. For this formula, we should have the solution of the to the s, and for this formula there are two solutions. Is v, the first one is v equals to 0, and the second one is determinate x plus s square m equals 0. So the v equals 0 should be ignored, and so we just need to figure out the second condition. So firstly, we need to write down the matrix of the k plus s square m, and we just write it from the previous form, a matrix, and combine it. Just first we write k, the first k times k2, and this one is minus k2, and then minus k2, and k2. Then we write this s square m. We just also plus m1 s square, and the m at this position is 0, so we don't need to write anything, and this position as well, so we only then we need to write the m2 as square. That's it. Then we need to write down the determinant of this matrix. The determinant should be calculated by times the products of this value and this values minus k, this value times this value. So we get equation, and this equation should be equals to 0. So simplify and put the number of the k1 and k2 and m1 m2 we got, and simplified this equation, we got this final equations. For solve these equations, we can assume the s square as a and rewrite these equations, and then we can solve the a at first, then we can get the s, and these are two solutions of s. So after we get the solution, we need to put the solution into the equation. And for the first condition, s squared equals minus 192, and put into the equation that we write, and we just plug the s square into this part, and we get the v1 and v2, and that equals to 0, and so we get the relationship between v1 and v2. v2 equals 1.4 for v1, so we define v1 as 1 and v2 equals to 1.404, and this is in phase mode shape. And then we need we used the second solution of the v squares, and also plug into the equation, and we get this, and we need to get the relationship between the v2 and the v1 as well, and then we get the solution of the v vector. This is the out of the phase mode shape. Finally, we just need to put these two kind of solution of v into the previous x that's defined as the v times est, and this is x equals to the v vector times c1 e. We just plug into the 192 square root, and positive and negative 1 in as the first, and the second solution 3475 square root, positive and negative as the second solution of the s, and correspond and pair to their v solutions, and we finally write the e form into the sine form, and we get the final solutions. This is my explanation.